heard yesterday some other, arms of the armed services are going back in. But the Air Force is really, not only is, I always knew it as the elite, I did not realize their 3 theaters. I did not realize that our alumni supervise 80,000 employees, of which the majority are actually civilians. Everything that the Air Force researches, buys, builds, comes through General Ellen Pawlikowski's command. And when I got the chance to meet her other 4-star counterparts, as well as the Chief of Staff who just retired, Mark Welch, brilliant man, and the Secretary, James, I met her as well in our 3 days. This is called a Corona. And in some of these meetings, we're not even allowed to bring a pen, pencil, paper, no electronics, and the briefings and the courtesy by which I'm in the program called the Civilian Leadership Program. There's about another 30 of us, and it's an opportunity to learn, but I'll keep a lot of it to yourself about what the Air Force does. And these are amazingly dedicated, hardworking, highly intelligent people who could be doing anything else in the world given their backgrounds, any other job. So that's a little about the Air Force and the quality work and the quality people who work in the Air Force. And I came back here and gave more money from the university budget to the Air Force ROTC. It's kind of a guilt thing, but you have to do something, right? So now they have a full-time secretary, which they didn't have before I went to the 3-day MacDill Air Force Base experience. And the other thing I didn't figure out I couldn't do, MacDill is where a lot of the tankers are. The planes that refuel the fighter planes, many of them come out of MacDill Air Force. Is that the command place for the tankers, Ellen? Okay, so that's one of them now. So they put you in this little cubicle and they want to see if you, as a civilian, can refuel a plane at 300 miles an hour. I wasn't even in the sky, never mind refueling a plane. Jeez. So Ellen Pawlikowski, she is a 1978 alumna of this university. 1978, so it was already NJIT. She's a chemical engineer. And if any of you know some of our chemi, I won't name them by name, Darren Hanishian or Angie Perna, I won't name them, but they take personal pride in helping her grow up, get educated, and be the highly, highly competent. Every time Ellen is here, I get Angie in my office, so when do I get some time with my student? So 1978, only the 3rd woman in the history of the Air Force to get the 4th star. And at the event, the Secretary and General Mark Welch spoke about her commitment, and she spoke about her commitment to family and country, and how she just excelled. And Ellen has got, I've heard her use the expression a couple times, she will never quit, and she'll try to do everything right, because that's who she is. She has come back here on multiple occasions. In fact, until the lawyers of the Air Force told her she could no longer be on the Board of Overseers, she's a member of our Board of Overseers. So the Air Force Materiel Command is, it's called AFMC. When you go there, you learn a whole new lexicon. I kept on hearing people talking about standing up missions. No idea, what are these people talking about? Or AORs, areas of responsibility. So my first evening there, I had an opportunity to learn, to get a dictionary from Ellen, if you will, to understand what it means to stand up a mission. Some of you may know this, of course, or to have an area of responsibility. But I also learned what the AFMC does for our country. She has just a legion of awards that she's received in her lifetime from the Air Force and elsewhere. And she is just an absolute pleasure to spend time. There are very few topics that Ellen is not articulate on, not only related to the military, but just life in general. So it is my pleasure to introduce General Ellen Pawlikowski. Ellen, please.
Well, first of all, thank you all for coming here to listen to little old me talk to you. I'm so proud to look out here among. Can you all hear me? Because I'm not sure. Can you hear me? Yeah. You know, this isn't my year for reunion. I'm class of '78, so if you do the math, it's an off year for us. So it was an honor when Dr. Bloom asked me to come and talk to you about what the Air Force is doing. He talked a little bit about my background and oh, I didn't turn it on. That's what the problem is. I knew it didn't sound like I was.
Okay.
All right. How's that? Oh. Hello? How's that? Can you hear me now? I got it. Okay, there we are. Ooh, now you can hear it. You know, Dr. Bloom he mentioned that he is part of the Chief of Staff Civilian Leadership Program. And a little bit of background about, you know, how he ended up with that. Oh, let me go back. I'd like to start a little bit of background on how he got into that program. There are 5 major commands in the Air Force, and once a year the Chief of Staff sends out a note to all of us. I'm one of those 5, and says, okay, I need some new members for our civilian leadership program. And typically a MAGCOM commander picks somebody from one of the bases that the communities around the bases that we have our folks in. And I have 5 bases that are spread around the country where Air Force Materiel Command people work. But he also sent out a list of areas of the country where there was underrepresentation in his civilian leadership group, and as well, frankly, in terms of the population of airmen, of those 300,000 airmen, and one of which was listed as the New York, New Jersey metropolitan area. So instead of picking from one of my geographic locations for the major command, I thought to myself, you know, there isn't anybody I know that would not be a better representative of the New York, New Jersey metropolitan area than Joel Bloom. And so that's how he got onto this program. And the reason why it is so important to us is that as a country, we need to be able to leverage in our armed forces folks from all over the country. We can't have a particular region of the United States that we are underrepresented in because, frankly, the power, the energy of our Air Force comes from the diversity of our people. It enables us to make sure, and then when I say diversity, I'm talking in a broad sense of diversity. I'm talking about geographic representation, because now having lived many different places in this country, and I know many of you come from now living in other places in this country, you know that this is not a homogeneous country. And we all come with very different perspectives in terms of where we lived and where we grew up. And I bring to the Air Force what I learned growing up in Bloomfield and going to school here. I like to say, you know, I'm not one of those good old boys from the South. I'm a street-hardened, urban, you know, New York, New Jersey representative, and I really felt it was important that we have others like me wearing this uniform. Second of all, STEM, as Dr. Bloom talked about, is critically important to the Air Force. You know, the Air Force, when you get around folks that are from the Army, and the Navy, the Marines, and the Air Force, how many veterans do we have out here, by the way? Yeah, we got a few. I know there's Air Force and there's Marines, and we all have different traditions and reputations. To the Army, it's all about the soldier. To the Navy, it's their ships. To the Air Force, it's our toys. We are the highest tech of any of the services, and you know we'll get the ribbing about that. But we are also the part of our national security that's never been afraid to bring a new technology into the battle space and use it as an effective tool to protect our national security. Going all the way back to the Wright brothers in the airplane, and then on to the first satellites, on to our ventures into cyber. So STEM is at the heart and soul of the Air Force. And so an institution like New Jersey Institute of Technology is very important, that we are able to leverage the tremendous talents and capabilities that come from this school, both for folks that are wearing suits like mine, but as Dr. Bloom mentioned, I have 60,000 of those 80,000 folks that work for me are wearing civilian clothes. So for me, it's not just the number of people that are wearing a military uniform that have a STEM education, it's also that civilian workforce. And one of your 1966 alumni was part of that civilian workforce, Jim Panini. And so that's very important. Otherwise, another thing that's important, by the way, Dr. Bloom mentioned the space fence. Well, you know, the space fence, what the space fence is a big radar. And it's used on the ground to track objects that are in space. Do you know who I happen to be the one who awarded that contract for the new space fence. Do you know where the contractor for that new space fence is? It's Lockheed Martin in Moorestown, New Jersey. So from my perspective, it's not just the 60,000 civilians that work for me, but it's a couple of thousand civilians that work for defense contractors in the state of New Jersey, that it's important that they have a place to get the engineers and scientists and program managers and accountants and contracting officers to be effective to deliver the products that I manage. Because in reality, the Air Force doesn't really build anything itself. We do almost everything is done essentially through contracts, although I do own my own factory because all the Air Force depots, which do the overhaul on the airplanes and some of our systems, they're all part of the Air Force Materiel Command. So a university such as New Jersey Institute of Technology is critically important to the future of the Air Force, which is critically important to the future of our national security. So for me to have the opportunity to come out and talk to all of you who are coming from all over the country in all walks of life about what the Air Force is doing is not just a nice thing to do for an alumni, but it's very valuable to me in terms of as an Air Force leader. I got to tell you though, I got my own Central High story. You know, when I was here, the ROTC detachment used to have a little lounge in the basement of Everhart. So we used to go in through a side door because they didn't want us, us students up in all the offices, because even then Everhart had all the offices. So we used to slide in that side door, which was right along that walkway between Central High and Everhart. And I am a witness of one of those desks that came flying out of that building. It was definitely always an adventure to go there. Go past that building. So my job today, as Dr. Bloom said, is I'm responsible essentially for cradle to grave for all of what we call weapon systems in the Air Force. That is airplanes, satellites, command and control systems, which are a bunch of computers that are used to orchestrate the battlefield, the training systems, what Dr. Bloom was talking about when he couldn't refuel that aircraft when he was going 300 miles an hour. That's a simulator that we have down at MacDill Air Force Base that's used by the young men who are largely enlisted that are actually in the airplanes, those tankers when they're flying, and their responsibility is to hook up with these high-performance jets and essentially pump fuel into them while they're flying next to them. So can you imagine that? There's a big boom that comes out of the bottom of the airplane, and this young, sometimes 22, 23-year-old is essentially guiding that boom into a small receptacle in that airplane, and then there's a marriage between those two airplanes as they fly essentially together with this pipe between the two of them as we're putting fuel into that airplane. Critically important because of our need to be able to go long distances, longer than what you can do on one tank of gas. So that capability is critically important to our reach. I'm responsible for all of that, to include the installations, by the way. We have people that worry about whether the runways are going to be need to be repaired or replaced or resurfaced. I have people that worry about global warming and its impact on our bases in Alaska. Everything, and then at the same time, the Air Force Research Lab, which I was a former commander of, which is the keeper of the Air Force future, as I like to put it. That's where our basic research and the technology development happens. And right now, it's a really important time for the Air Force and for Air Force Materiel Command, because we are looking at, you may have read about this in the press, something called the third offset. And I don't know how many of you are at all familiar about what the third offset is, but it is what the Department of Defense leadership has brought forward to the President of the United States as the strategy for us to maintain our national security 15, 20 years from now. And if you're going to make that happen, people like me in Air Force Materiel Command need to start working on it today, because you don't turn around. It takes 7 years to build a satellite. So if we start thinking about what that satellite needs to look like today, maybe 12 years from now we launch it. So for Air Force Materiel Command, the third offset means we got a lot of work to do to turn this thing into what one might argue is a theory right now, and a few hypotheses about how well this is going to work. And so it's up to me and my fellow STEM grads, if you will, in the Air Force Materiel Command, to take those, those kernels of ideas and put some real engineering and some meat behind them and turning it into a reality, so that when our young Americans, who all voluntarily put themselves in harm's way for us, it's an all-volunteer force, has the absolute best opportunity to come home safely. So I thought what I would do is, first of all, talk to you a little bit about what is the third offset, and then what are some of the neat things, cool things that we're working on in Air Force Materiel Command that are going to get us there eventually. So first, I know, especially all you engineers are out there, okay, it's a third offset. So what was 1 and 2, right? We all ask that question, right? So let's talk about what's an offset strategy. And so let's talk about the first offset. Okay, it's the end of World War II. Let's see, 66 grads, so no, we have no World War II veterans in here, do we? We do. Okay, outstanding. So it's the end of World War II. What happens, which is the American way of war, the war ends, we all come home and we take those uniforms off, right? We downsize our army. We are not a country, our American tradition way back from the early Revolutionary War is we do not have a large standing army. That is not what we value in this country, right? We are citizen soldiers, all of us really. A small amount of folks like me, but for the most part, we do not have large standing armies. However, we were not the only country that exited World War II, and there was one country in particular that did not take necessarily that same approach, that being the Soviet Union. And so for those of you who, I know some of the veterans we have in here were served before they came to school here. Those of you who lived in that era know that the big issue was the large standing army with tanks and equipment on the Fulda Gap in Germany. And we were not, as a nation, prepared to send thousands of young Americans to sit on the other side of that gap and to help to defend our ally then of Germany. That was not what we wanted to do. So we needed something to offset the large numbers and conventional weapons that our adversary had. Our response was to leverage technology, which in that day was nuclear weapons. And so it was during that era, right after the war, that we built up our air-dropped nuclear weapons. Nuclear submarines came into reality, and our Army even had tactical nukes. And that was our offset, if you will, from not having a large hundreds, thousands of Americans in uniform to go mano a mano against large force on the other side. American strategy in war, yeah, when we go big, we go big, but we're not really interested in putting an awful lot of people in harm's way. Minimum collateral damage. Now, nuclear weapon is not necessarily minimum collateral damage, but nonetheless, it is an extremely good offset that makes one think twice about whether you're going to step over that line and unfold the gap. And it was extremely effective for us for decades. However, we found ourselves in situations where perhaps a nuclear offset was not exactly the most appetizing thing for us to do. So we needed, as we got into wars like the Vietnam War, where we once again were faced, we turned to where could we once again leverage technology that would enable us to be able to have the unfair fight on the conventional side, because that's usually our objective when it comes to our military. We're not interested in a fair fight. We're interested in having the ability to overwhelm. So the second offset was born, which had to do with leveraging primarily two technology areas, and I venture to say there was probably some of that work that was done here. The first of that was precision munitions, using GPS-guided munitions, using laser-guided munitions, opticals, which now enabled us to be very precise in when we dropped a weapon, and we could do it from longer distances and further out, so that we didn't have to put our pilots in harm's way. And then the second thing was stealth. You see the 117 there. That was the Air Force's first stealth weapon. And that enables stealth is a technology that protects our aircraft from being able to be seen by radar. That's what we mean by stealth. So those two things together provided us that second offset, that offset us when it came to the conventional. And the first war you saw this come to fruition in was the first Gulf War. And many of you remember the pictures, if you will, that came from Baghdad that first night, where we saw the bombs dropping into on buildings and very precisely going down. We had techniques that were developed, which we called the triple miracle, where in order to get further in, because of the precision we could get with these weapons, we would drop one weapon down that would open the hole big enough so it would get farther down, then we'd drop it exactly the same place, a second weapon that would get a little deeper, and then we would drop it exactly that same location, another one. And so we were able to, leveraging technology, the precision we would get, and the ability to penetrate through the radars, that was the second offset. So the Air Force that I started growing up in, and the world environment that many of you, as I look around, was that of a Cold War, right? One adversary countering him with nuclear weapons. We then saw ourselves in the environment where we had to have conventional capability. But nonetheless, and then over the last 10 years, we've seen ourselves in a war against violent extremism. Starting with 9/11, and I tell you, that's one of the things that was so gut-wrenching to me when the first time I came back. Jeremy and I were looking at it last night and drove along MacArthur Highway, and they were gone. And you know what I mean when I say they were gone. I grew up with those two towers and being able to see them across the river. And so it was a very significant emotional event for us, and we've been doing that now for the Air Force. Dr. Bloom mentioned that, we're sending troops back into Afghanistan or Iraq. The Air Force never left. We've been fighting there. We have remotely piloted aircraft that are providing intelligence and surveillance 24 hours a day. Our airplanes are there providing bombing attacks against the ISIS campaign, and we've got others providing close air support command and control, all of those things. So if we look at the world today, we see that we've got radical extremism, and that has not changed. How many in here 2 years ago knew what even heard ISIS, right? And now we've got major activities going on to it. But we can't just be focused on that piece anymore, because while we're doing that, this little gentleman over here, you know, the Russians are our friends, yeah, until they walked into Ukraine, right? And then right after they walked into Ukraine, the good President Putin announced that he was going to buy 20 new ICBMs. So, you know, we kind of had forgotten about that nuclear piece, right? Not so much. And so while I was focused over here in Afghanistan and Iraq, now I'm looking, my good friend General Lawrence, who's the European commander for the Air Force, is crying, wants some of those airplanes, wants some of those weapons to help to support our NATO allies. Then, you know, we got this guy over here who's, you know, popping off his tests. Remember that nuclear piece again? And ICBMs and ranges? And then space, the new frontier. We're off on our own. You can launch anything. Big space, don't worry about. Nobody's going to threaten you up there, and most of our satellites were launched with that in mind. And then, I guess it was about 5 years ago now, the Chinese launched a rocket, broke up in space one of their own satellites. Now they practiced on their own satellite. They didn't practice on their own satellite because they plan on using it to clean their own satellites out of the orbit. They practiced because they're looking at ours. So space now is a contested environment. And that's why that space fence that's being built down in Morristown is critically important, because the first step to being able to defend something is to understand what's going on there, right? So I need the space fence and other capabilities of that so that I can track what's going on. Then there's this other, cyber. You know, you may have read about it in the press, about the breach of the Office of Personnel Management. I got one of those letters. Most of my friends got one of the letters that said, hey, your information, because we all had security clearances, and filled out all those forms in great detail. And I will tell you, it's not just personnel information. It's been sucked out. So that's another area that we have to worry about. And then there's this little piece here. You know, what you find, what I've learned, particularly in the job I'm in now, because everything that happens in the Air Force, we have a part of making it happen, is, you know, when the world gets in trouble, they call on the United States. And when they need stuff delivered somewhere with capability, they call on the United States Air Force. So how many of you remember the Ebola outbreak in Africa? It was about 2 years ago, right? Maybe now. I'm there with the Surgeon General of the Air Force, a 3-star general, planning on how we're going to fly 7 tons of equipment to Africa with airmen, doctors, nurses, medical technicians. And arguably, the efforts of the United States Air Force prevented what could have been an international pandemic in Ebola. Not something that you would think about for your United States Air Force, would you? But the fact of the matter is, as a nation, that was important to our national security, you know, to our security, to our well-being. So the interesting thing is that no longer are those 2 great oceans that have always been our great borders all that good in terms of defense, when they can reach out and touch us through cyber. Could have been a bio-8 attack instead of, you know, a natural occurrence of Ebola. And then economy. Just 6 months ago, when the Chinese were struggling in their own market, I don't know how many of you own stock, but it was pretty uncomfortable for about a month there, wasn't it? As we watched our stock market go down. So when we approach our national security with this environment, we've got to be able to have the way to be able to respond to a wider breadth of threats than back to when I first came in the Air Force, when we were worried about essentially one adversary, and it was, you know, nuclear weapons versus nuclear weapons and a little bit of standoff on the conventional side. What that means to me, it means to our Air Force, is that we rolled out a new plan, strategic plan, about a year and a half ago now, with the focus on strategic agility. We need to be our Air Force, in order for us to provide the kind of capabilities I just described, to be responsive to something that's going on here, and then at the same time be able to hop over to Europe, and then at the same time go over and defend our presence in Asia, because Asia is an extremely important part of our economic well-being. You heard Dr. Bloom talking about being over in China. We have got to have the ability, the agility, to be able to respond to these different things. We have to be able to leverage, be more inclusive in terms of what we explore and how we look at technologies. That's why you see Secretary Carter trying to establish, if you will, outposts in Silicon Valley. And there's going to be another one that we're standing up in Boston. And I'm like, well, why not New York, New Jersey, right? Where we can leverage innovation like NJII to be able to make sure that technologies that are being developed in the commercial sector we can use. So this means for me in Air Force Materiel Command, if we're not agile, the Air Force can't be agile. Because if I take 12 years to bring a new weapon system, a new airplane, a new bomb, a new air-to-air missile, a new radar, that's too long. Several generations. So we have a major effort on the part of Air Force Materiel Command to be more agile, to be more responsive, to be more flexible, to be more adaptable in how we do our job. At the same time, the products we deliver have to be more adaptable, have to be more flexible, have to be more responsive. So we are exploring ways of systems engineering that we've never thought about before. Example, much more commonality among the different aircraft we have, something we call open mission systems. The software and the hardware that go into our different aircraft. We have F-15s that have a certain mission, and F-16s, and F-35s is our new fighter, and B-21 is our new bomber. The way we have built our aircraft in the past, I buy a radar from Lockheed Martin. And if I want a new radar in that aircraft, it's a major effort to replace it. In fact, I got to have Lockheed Martin there because of the proprietariness of all the interfaces with it. Open Mission Systems is an engineering approach that allows me to buy maybe the next radar from Northrop Grumman, because I define the message traffic, I define those interfaces with a common set of standards, if you will, that enables me to do that. Think about what that does for me in terms of my agility for bringing new capability on board to these airplanes. Those are the kinds of things that I'm exploring to increase our agility. But the Air Force's focus on strategic agility is really a part of the bigger focus on the fact that while we were spending all of our time here, these guys caught up in terms of our stealth capability, in terms of our precision weapons. You probably have heard in the press that the Chinese have built these islands, which allows them to bring their military presence further out, which allows them, so now my stealth isn't as good because they got really better radars than they used to have because they've been studying my stealth. And my GPS doesn't work as well because you know what? They're jamming my satellites. And so now I need another alternative because I am no longer going to be able to defend our national security without an offset to what the Chinese and the Russians have been doing over the last 10 years while we have been focused on this fight and all these other things. So the third offset, oh, I'm sorry, I was supposed to be clicking this as we go along. Those are all our toys that we're using in each of those areas. I kind of talked that. This is the Center for Strategic and Budgetary Assessments, one of those think tanks in the DC area that talks about the new offset. And it, like this first and the second offset, is all about what are those next breakthrough technologies that I can leverage that will enable me to continue to be the, if you will, the American way of war, which is to not put hundreds of thousands of young Americans' lives at risk unless I absolutely have to, like we did during World War II. How can I leverage technology to enable me to be able to reach deeper in and still be effective even since I've lost my second offset? The answer to that is a series of technologies which essentially allow me to build what Deputy Secretary of Defense Work calls the battle network. And those technologies are really bringing the Air Force and the other parts of the military from the, if you will, the industrial age into the information age. I need to be able to have information flow be ubiquitous throughout my network so that when I have a satellite and it sees something, it can directly communicate to an aircraft potentially that has a weapon on it that now can see very much deeper than it can go, because that satellite can see a lot deeper into China, for example, than that airplane's radar can, because we're trying to stay outside of where we're at risk from this. So the third offset is about, a lot of it is about that human-machine interface and being able to leverage what the information technology, something called autonomy, which is a study of, you may be familiar with the term artificial intelligence, but autonomy it enables me to take a robot, in other words, and actually have a degree of independence than being controlled by somebody with a joystick. So a weapon systems, if you will, that can make their own decisions, that can fly together as a team without having a human essentially controlling it. Critically important if you think about whether I can reach deeper in and still keep my pilot from my airplane safe and be able to disperse out so that I can make it too expensive and too hard for somebody to shoot down hundreds of swarming autonomous weapons carriers, for example. Another area that's important to this is something called hypersonics. Now, hypersonics gets me a very, very high-speed weapon. So that way, when I get that message from the satellite that says, hey, there's something I want to shoot at, and it's released from this aircraft, it can go very, very fast to that target and get it before that target moves. Hypersonics is an area that is just in its infancy in terms of being able to, it's been studied for a long, long time, but it's finally at a point where we think we can bring it into a capability. And then another area is directed energy. You know, I know, I'm looking out there, a lot of us grew up watching Star Wars and Star Trek, right? Where they use their photon torpedoes and, of course, the handheld phaser, right? Well, we ain't got any of that now. But the technology has been maturing slowly but surely, and we are now on the cusp of being able to actually field laser weapons. It's not as easy as they made it look, by the way. Not at all as easy. So that's a challenge for us. So the third offset is about leveraging big data. in the context that I can get information about what's going on, let's say in China from satellites, I can get it from the internet, I can get it from maybe the bordering countries. But that's a lot of information for the human mind to digest and come out with an answer. So big data is important to me because I need to be able to bring that to the battlefield. I need to bring communication because, you know, the airman of today has grown up with his cell phone, with social media. He collaborates, he or she is a collaborator by nature. Our weapon systems of today don't provide that environment for him. We don't have the communication capability. We do not have the internet, if you will, to do that. We have to bring that to our airmen so that they can leverage what the capabilities they have. So that's the third offset. The third offset, if you will, is this battle network where everything's connected and I'm leveraging the human-machine interface so that I can effectively use machines, if you will, to fight my battle. And now, this is where there's a social part in science and part of this too. Because all of us have watched the Terminator movie and we all watched the drone armies going forward. So when I talk about a thinking weapon, an autonomous weapon, how do I train that with the moral standards, with the moral decision making that our American airman does today? Right? How do I not become the Terminator, if you will? So this is the challenge for me in Air Force Materiel Command, because you remember I'm the keeper of that technology. So I have scientists and engineers in the Air Force Research Lab that are on the cusp of providing that. And so I'm very proud of them. And I wanted to the last thing I want to talk to you about is to show you some of the things that those guys are doing. This young lieutenant here, he's about 2 years out of school. He's stationed down at Eglin Air Force Base, which is on the panhandle of Florida. These are his toys, if you will. Those are small, low cost, semi-autonomous, meaning that they have some autonomy. And he is working on the technology and the concepts of swarming weapons. So if I'm going to go in and I want to avoid a whole bunch of shooting down, send about 100 of those in. And quickly, if you do the math, I present a very costly challenge for my adversary if he has to shoot each one of those down. But importantly, they're not just lemmings. They all think for themselves. But there has to be some connection to the human in order to make sure they get pointed in the right direction. And so his job is to figure out how one person can control as many of those as he possibly can. Because I don't have 1,000 airmen sitting down there, each one of them with a joystick flying these. I've got to be able to. So he's up to about 4 now. He's about ready to test 4. And then he kind of goes up by a 2 factorial, if you will. So we're pretty excited about that work, and that's why I need NJIT grads, right? Because I graduated from NJIT and then I went out to Berkeley, and I've spent a lot of time with folks like from Berkeley and MIT and Caltech, and they would tell me that I graduated from a blue collar engineering school. Well, you know what? Damn right. Because an NJIT grad can go right out and start doing something like this. You know, I may have struggled a little bit with the theory when I first got to Berkeley, but Angie Perner will tell you that there was a steady stream of chemies out to that Berkeley Chemie department because they valued us in terms of what we brought. So I need young engineers that can come in and do this kind of thing. This is an F-35, which is our latest fighter aircraft with an F-16. We're going to take, right now today I've got scientists and engineers in the lab that are essentially turning that F-16, which currently is a manned platform, into an unmanned platform. And this F-35 pilot is going to be controlling that F-16. We call this the loyal wingman. And this is an attempt to see how much we can do with flying in formation with unmanned vehicles. You may think, okay, pretty straightforward. Not so easy, right? So we've got an effort here to see, first of all, how much autonomy we can give that F-16, because that F-16 could be carrying an extra set of weapons that would essentially be able to be launched from long distances based on sensors that are inside the F-35. And so we are looking at how much can I teach this so that it can make decisions on its own, because I can't have, the F-35 pilot's got a lot to do in his own airplane. It's pretty busy in there. Lots of sensors and flying, so he can't fly both of those at the same time. So this is our if you will, our experiment on how well can we combine manned and unmanned to fly together. Everything from automated collision avoidance, so it doesn't run into the F-35, to that moral decision making, if you will, or do I launch the weapon or I don't launch the weapon. So that's another area. This one down here is one that you might think isn't all that applicable when I talked about the third offset, but for me, for Air Force Materiel Command, that actually is very critical, and that's additive manufacturing. That's one of the things that we talked about when we got together. Now, what additive manufacturing, remember, I'm the person that's responsible, my team is the people that are responsible for keeping these airplanes flying. That means that I'm responsible when an airplane goes and deploys, as we call it, and is stationed in Kandahar Air Force Air Base in Afghanistan, that all the parts are there for when the plane needs to have things replaced. They're there, and we can turn the airplane quickly. Remember that agility thing, right? Well, today that is done by building these big kits. We ship them over, and then we use people like FedEx and our own airplanes, and we have warehouses full of parts that we inventory and we buy, and then we have all this money tied up in these parts. What if I could, instead of sending a kit over there, I just have some 3D printers and the designs for those parts. And if an airplane comes down and it needs a part, the technician just goes over and finds the right the right file, plugs it into his 3D printer, walks away, and comes back maybe an hour or two later with the part that he needs to fix the airplane. Boy, that improves my agility. Remember I said I'd be agile. And think about what I save in terms of investment in warehouses and parts. Now, I don't know if we can get there. That's why we were talking about it, because not everything can be 3D printed. And it may not be any cheaper. That's one of the things I'm learning. 3D printing is it. But I can tell you today, I have parts in our airplanes that were 3D printed. I meant to bring it with me and I forgot, but I have, the B-52 is one of our airplanes. Many of you remember the B-52s are older than most of the people in this room. And some of you are pretty old. With all due respect, sir, but World War II vet, we're celebrating the 75th anniversary of some of the events, so he's older than the B-52, but only by a little bit. I still got to keep those flying. So we have parts on those airplanes I can't get anymore. And so what do I have to do? Typically what we do, we have an impeller, a fan impeller. When you say a fan impeller, can't be too high tech. Plane don't fly without it, right? 200 pieces in this impeller. And you know what? The guy who manufactured it back in 1953, he's not in business anymore. So how do I replace it? Typically what we would do is we would hire a couple companies, they would reverse engineer it, they would demonstrate that they could build it, we'd qualify it, and that would take about a year. And then we'd start buying them. Small business, leveraging some small business innovative research that was done, is now building the impeller using a 3D printer for us. It took 3 months instead of a year to get the first one. And now whenever I need one, we just print it. And I don't have a warehouse full of those parts. That's why 3D printing and advanced manufacturing is important to the third offset. So the cool thing about my job is we get to think about these things and make them happen. And you can see why across all of this, how much I need a good STEM institution in this country. Because oftentimes the challenge I have is being able to have people that can get the security classifications to work on these things. And so I value Americans that go to school in places like NJIT and can come, and whether they work for me or they work for Lockheed Martin or they work for Boeing, it doesn't matter, because they're the ones that are making this happen. One last thing that is in a way related to your NJII, is something we call development planning. Now, the challenge with technology is it doesn't know its application until we tell it. Right? It's a real cool thing. Guys, scientists is developing it. Spent a lot of my career dealing with scientists. They're very infatuated by demonstrating they can do something. And there's people in the world like NJIT grads who I call bridgers that are able to see this technology and they know there's a problem over here and say, you know what, I think we can use that to fix this, and the scientists didn't even know it. So we have to do that better than just by chance in the Air Force. I have to bring my technologists and my scientists and engineers with those F-15 pilots, with that tanker, that airman that was back in the back of that tanker, and engage on a regular basis to compare notes, if you will. Tell me what you need, tell me what you got, here's what I need, here's what I think I got. Well, let's try it. Does it work? Maybe not, but you know what? I can change what how I use it a little bit, and oh, I see what you want, so now let me go back and work on it. So we call this the development plan. We call that activity, that engagement between, if you will, the operator and the scientist, developmental planning. Because typically you're doing this for looking at something 10 to 15 years from now. And we call this the donut because it's an iterative process. So input is what are the capability problems, the challenges, and what comes out of research. We throw them in here. We have to do this as low cost as possible. So that means that we can't start by building things. So we very heavily leverage modeling and simulation. Because I can do an awful lot of experiments and tests with electrons in a model before I actually start bending metal and spending a lot of money. So we start with some modeling. We go to what we call rapid prototyping. That's building a piece of hardware very quickly. And then doing that in exercises. And what comes out of this is my scientists get a better understanding about what's really needed. They come away and say, yeah, now I know what you want. Let me go back and work on that. We know what technologies are going to be the real ones that pay off. Wide breadth, when we get into the first part of this, we narrow it down because we don't have infinite amount of money to spend on every technology. And then out of it comes, hey, if you can really give me that, then I may be able to do things a little differently. That's concepts of operations that change. So we go around this cycle and continue to take those technologies I just talked about and share them with the guys that are actually going to go out there and fight the war and develop how they're going to do it, and my guys get the information about what they need to do for their next step. So this process is critically important to the third offset as well, because remember, technology doesn't know its application until we tell it. And we never know how we're going to use something we build until we put it into the hands of the airman that's going to be using it. And so this process allows us to do that. And this requires the kind of wide breadth and cross-functional type of discussion and dialogue that NJII does, I think, right? I mean, that's the kind of thought process that we use when we do development planning. So the future of our national security rests with the third offset. And the beginnings of that third offset is happening today in Air Force Materiel Command. And I'm personally just feel that I'm extremely blessed to have the opportunity to continue to wear this uniform. I graduated from here in 1978. I went immediately off to graduate school at Berkeley because Angie Perna wouldn't leave me alone unless I did it. Took an educational delay, came on active duty in 1982. That was during the last great energy crisis. You remember all the lines? Had numerous job opportunities when I wasn't even looking for a job when I graduated because I had my commitment to the Air Force. So my plan in 1982 was 4 years and out. Kind of screwed that up, didn't I? But I got to tell you, I've never looked back. It's just great to be able to continue to serve this great country. And then it's just amazing to be able to come back here and to share experiences. I got a chance to meet with some of the veterans in the class of 66 this morning and kind of compare notes. And, you know, you got to be proud about being from NJIT when you listen to some of the great accomplishments and the service to this nation, regardless of whether you're wearing this uniform or you worked for the government, that our graduates are doing. So it's always a pleasure to come back here, and I really appreciate the opportunity, and I probably blew your schedule, but I just get so excited about talking about this stuff. And I apologize, I tried really hard not to use too many acronyms for you, but it's kind of, you know, in the nature of our language, but I appreciate the opportunity to share with you and maybe get a few minds thinking about what that third offset can be and what it could do. And I'm always open to ideas. I love ideas, so don't hesitate to share them if you've got some. All right, thank you.
I can't help it, but as we were listening to the general,